This video describes how to measure insecticide residual efficacy in long-lasting insecticidal nets, or LLINs, as recommended by the World Health Organization, or the WHO. For the methods of delivery of long-lasting insecticidal nets, see the video on this topic. Once the community has received LLINs, the residual effect of the nets needs to be evaluated periodically to see if the insecticide is still working in relation to the length of time in use and the number of washes. This test also enables programs to determine when to replace the nets. The application of this methodology is the responsibility of laboratory professionals and entomology technicians. Usually, you use fully susceptible mosquitoes reared in an insectary to do the evaluations. Where this does not exist or cannot be obtained, then a less than desirable but necessary alternative would be to use field-caught mosquitoes. To use this alternative, you need to determine that the field mosquitoes are susceptible by performing a susceptibility test. To learn more about this, watch the video about susceptibility testing. For each net to be evaluated, 60 adult female mosquitoes are needed. For each cone, you need 5 mosquitoes. For each treated net, you need 10 exposure cones and 2 control cones. Usually, non-blood-fed female mosquitoes between 2 to 5 days old are used for the test. The temperature at which insecticide exposure occurs, ideally 27 degrees plus or minus 2 degrees Celsius, and relative humidity greater than 60%. Generally, a bioassay kit contains the following materials. Aspirators, or sucking tubes, are used to collect the mosquitoes. For these assays, you need 2 aspirators, one to transfer the mosquitoes to the control cones and another to transfer mosquitoes to exposure cones. A slight angle at the end of the aspirator will help in collecting mosquitoes from the edges of the cones or cups. Rubber bands are used to attach the cones to the net. The control cones should be attached to an insecticide-free net. After the mosquitoes have been inserted into the cone and exposed to the net for 3 minutes, they are transferred to covered cups. This test can also be done by taking the net down and stretching it over a piece of cardboard following the same procedure. It is advisable to take along an untreated net to use as a control since it might be difficult to find one in the field. Following WHO guidelines, the study sites should represent cultural settings and environments where LLINs are distributed. Each site should be large enough to have enough nets to allow for sufficient numbers of nets during follow-up. Place 2 cones on each side of the long-lasting insecticidal net. On the lateral sides, place cones towards the top and the bottom to get a better idea of the overall residual efficacy of the net. Place 2 cones on the top side as well. After all the cones have been placed on the long-lasting insecticidal net, label each one. As a control, attach 2 plastic cones to an insecticide-free net similar to the treated long-lasting insecticidal net. Introduce 5 unfed female mosquitoes into each cone and leave them in the cone for 3 minutes. After 3 minutes, remove the mosquitoes from the cone and transfer them to a clean container cup with cotton wool soaked in a 10% sugar solution. Use a different cup for each cone, and they should be labeled to correspond with the numbers on the cones. Write down the number of knockdown mosquitoes in each cone an hour after exposure, and the number of dead mosquitoes 24 hours after the exposure on a data collection form. Note the temperature and relative humidity in the area where the bioassay was performed on the data collection form. The container should be kept in a cooler, maintaining relative humidity by placing a damp towel over the container. The mosquitoes from the control cones should be stored in a different cooler to prevent contamination. Once the test is finished, the mosquitoes should be stored in properly labeled vials. The vials should have a small hole in the lid to allow the escape of moisture. They are then packed in airtight bags with silica gel to keep them for morphological identification and for molecular identification if required. In the laboratory, mosquitoes used in biological tests should be identified taxonomically to determine the predominant species evaluated. The mortality rates are calculated as follows. Control mortality, C, equals the number of dead mosquitoes divided by the total number of mosquitoes applied to the control cone multiplied by 100. Exposure mortality, E, equals the number of dead mosquitoes divided by the total number of mosquitoes applied to the exposure cones multiplied by 100. If control mortality is between 5% and 20%, the exposure mortality should be corrected by using Abbott's formula, where corrected exposure mortality equals E minus C divided by 100 minus C multiplied by 100. If the mortality rates are corrected, write down the corrected rates in the data collection form. If control mortality is greater than 20%, the experiment should be discarded. A long-lasting insecticidal net is losing its effectiveness when the average mortality is less than 80%. In this case, it is necessary to consider redistributing mosquito nets if there are resources available and the community is willing. Even if residual efficacy is still high, it may be necessary to replace a net if it is torn up or has large holes and its function as a mechanical barrier is undermined. The results for each sample net should be combined and averaged to determine if the nets in that area meet the WHO efficacy requirements stated above. If 80% or more of the sampled nets retain bioefficacy after a period of 3 years, then it is confirmed that under the local conditions of use, they are classified as long-lasting insecticidal nets. Since periodic sampling might be necessary to monitor the efficacy of LLINs, draw a sketch map showing the location of households sampled. If a GPS unit is available, take the geographic coordinates from where you collected your sample, remembering to record the latitude and longitude in decimal degrees. As you perform the bioassay, you should give each house a number. Against this number, record the location, number of cones used, knockdown rate, mortality rate, and date. You have now seen a general overview of how to perform residual evaluations on long-lasting insecticidal nets. As with any methodology, practice is needed to improve technique. For more information on integrated vector management or training materials, please visit our website.